Hello, Common Lisp the Language, 2nd edition, Chapter 5 we're doing today, Program Structure. So, Lisp programs are organized as forms and functions, right? And we'll talk about what these are in a moment. Forms are evaluated to produce values and side effects. So, throughout all of Lisp, these forms, these executable units, they basically produce either a value, or actually they pretty much for the most part produce values, which means the result, for example, of a function. In other words, that's their value or values, because we all know that Lisp can return multiple values, or side effects. So side effects basically means like things such as printing something on the screen, or making some kind of cool graphical thing that does something jump around the screen, right? So functions are invoked by applying them to arguments. Right, that's basically, that's the language and lingo that's being used here, that you have a function, and then it's invoked by applying that. I mean, the function gets applied to the arguments. Okay, let's talk about practically what forms are. So forms basically are the standard unit of interaction with Common Lisp, right? And essentially, it means a data object that is meant to be evaluated. And this is even evaluated, you might think about that as calculated to come out with a result. Right? Now there are three types that are meaningful. One is self-evaluating forms, and that's why, by the way, it's somewhat vague till now. Self-evaluating just means, well, numbers, symbols, and we'll talk about that in a moment, meaning things that essentially have a static value that doesn't change. Right? That's one type of form. The second type of form is a symbol. A symbol is, well, a variable for this context, right? You got quoted symbol, would technically speaking be self-evaluating, right? But a symbol, right, which stands for variables, right? That's the second type of form, right? Meaning that when a form with a symbol, which is nothing more than just a symbol, goes ahead and executes, it returns the variable's value, right? And then the third type are lists. And of course, lists can be divided into special forms, macros, and function calls. This is the real nitty-gritty. This is the stuff that executes. This is the stuff that does all the cool stuff. So your special forms, macros, and function calls. And we'll talk about what these three things are in just a moment. All right, so self-evaluating forms, so numbers, characters, strings, and bit vectors, which we've all talked about before. Those are all examples. Constants, for example, like nil, right? T, true, right? The empty list, which of course is nil. Those are things essentially that are all self-evaluating forms. In addition, there's an entire package where everything in that package is self-evaluating, and that's the keyword package. And that is where we have things like :start, right? He says which we're of course evaluating it will be :start. So basically, the keyword package is a symbol that will always evaluate to itself. Again, this is significant in that these, again, represent the smallest developments that we work with. And the one important point is like this, is that in addition, right, it's important, is that constants, these are self-evaluating forms, can't change, of course. They are sort of permanently the way they are. Now, what happens if I make such a constant, right? If I create a constant, if I go ahead, right, and I use quote, right, which basically says everything in here will never change. This is a quote. This is static, right? Then essentially I've created this self-evaluating form which can't be changed. Well, the thing is that sometimes it can be changed, but just because something can be changed doesn't mean you should change it. And let me give you an example of that. Okay, in this little example, I have basically two different variables, my list and my const. Now, again, if I use Lisp, right, which is a form which has a special form that returns a list object, 1, 2, 3, 4, right? If I go ahead and I decide to change the second value, that 2, to a 5, right? So, well, everything works as expected, right? 1, 2, 1, 5, 3, 4. Now, what happens though in a case where I decide to change my list to my constant? Now, remember, right, he says that using a single quote essentially is equivalent of quoting everything in here. So everything here is a constant from beginning to end. And now what happens if I go ahead and I change this? Well, the answer is, you're going to see in a second, for the most part, this is actually a bit of a problem. It actually worked. The only problem with this, that is an error. And in fact, the problem with that is that because the way things work, there's a potential of issues coming up where, let's say I stuff something larger or smaller and all kinds of other different things, or the compiler could have used that constant in multiple places, etc. This could create some serious issues where I'm not changing in place. In other words, a variable, I'm changing in place a constant, and that is an error. Even though it may work, keep that in mind. Weird, bizarre things can happen. So variables. So these are symbols. What's going on here? Here we go. Variables. Symbols are used as names of variables, as we saw, for example, our mylist, myconstant before. Same sort of idea. These variables can be assigned values, meaning, for example, in the case of our def parameter, right, I can go ahead and use setf, setq, and other forms of assigning the variable, or they can be bound, meaning with essentially using let, meaning they make let start, actually function parameters. Those are all examples of variables that are created by bindings. In this case, those are all lexical bindings, local variables, right? So basically, that's a lexical type, sometimes called static, but of course you'll confuse everything about a person who is in the C world. If I tell him static, he won't know what to do with himself. He'll just say basically that every time you come to speak to him, well, he says he's the same guy every time. Okay, anyways, bad joke. All right, special or dynamic variables, those are generally global variables, things created with def parameter, def val. Those are the two kinds of variables that we generally see. Again, it's a lexical or a special or dynamic variable. Okay, the dynamic variables, these global variables, they also have what's called a global value. As we discussed when we talked about extent and scope, it's possible to sort of override temporarily the value of a global, right? In that sort of neat kind of way that Lisp has. That makes them also special. That's why they're called special variables. So global values are the default values, meaning when they're not assigned in a way that essentially masks their value for a little while, it goes back to the global value. And that's the default value when it's not dynamically bound. Now, you can, of course, create using defvar a dynamic variable that has no value at all. It's unbound. You can actually use the function makeUnbound to set it to be unbound. All right. Okay, so certain global variables are reserved as named constants, like t and nil, true and false. So symbols defined by def constant, they also take upon themselves a constant variable. Constant value, excuse me. Now, one thing that's important to remember about def constant, we've already talked about, right? And that's the idea that they have a bit of an issue actually, we talked about def parameter, how you can use a constant value, a constant object, basically, and then make problems with that. Let's talk about for a moment actually here on the variable side. So def constant it has this property that essentially, if you redefine it, it has to be EQL to the last time it was defined. Now, what that means, practically speaking, is def constant can only be used for numbers and for symbols, right? So don't think about def constant being where you're going to stash basically lots of strings, and don't think of def constant where you're going to stash a bunch of lists. Just keep that in mind. Def constant is just for numbers and symbols. Very important. Okay, special forms, right? So special forms, that was the second type of form. The first form, like I said, was essentially the self-evaluating forms, and the special forms are generally environment and quoted constructs. Well, what that means is that they're generally used for affecting the environment or doing control structures in their project, controlling what's going on in Lisp. And those are things that essentially the Common Lisp compiler has to provide for you. These are like the key elements of Common Lisp before you start programming Common Lisp with Common Lisp to extend the language to be the entire package we call Common Lisp, which is the entire standard and all the various standard library that comes with it. Now, what it practically also means is something else. These are not functions, and therefore what happens is our little macro reader macro that can pull out the value, right, for the address, the function, right, does not work with them, right, because they're not functions, right? So it doesn't also work with macros. It only works with functions. And then I can, for example, let's say I'm doing a map car. I'm going to go ahead and I'm going to apply a function against an entire list, right? So that function, which is now going to apply, boom, 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 boom. And remember, it has to be passed, well, by, again, in a way that it can be used, which is basically the actual function's address. Now, the bottom line is I can't use that here. So that's just an important thing to keep in mind. So again, when we're talking about control structures, ifs and else, return from, go, right, throw, all these sorts of things. These are all examples of, those are non-local exit, by the way. Versions mean that the software didn't run its course. It got to a certain point and something said, go, get out of here. So go is like your classic basic go to. Throw, of course, we're talking about the exceptions, in this case, or the condition system. And return from. Return from is actually pretty cool. Most people don't realize that, but actually in a block that's named, so like for example, like a function, I can put return from function name, and then I can put a value. And at any point during a function, I can return with a value or values, right, that I'd like to return. In other words, when the form is done completing evaluate. I mean, I can change the form's evaluation using return from. Okay, so names of all common list special forms. Right, these are the things, right, that's pretty much kind of like you implement this and you have the basic common list and then you start really doing the implementation on top of that. All right, let's see, macros. So macros, right, some of the coolest stuff in Lisp, but if in fact what you come across, right, it's sitting there in a list, right, so because it's in a list, you know that it's not a symbol and you know that it's not a self-evaluating form, so therefore you're left with the other list forms. So we had the special forms version of the list forms, now the macro version of the list forms. So if it's not a special form, maybe it's a macro. So the system says, oh, my macro, and he goes ahead and checks. And essentially a macro is essentially a function from forms to forms. So basically it's actually a function that produces forms, which is pretty cool. So there are of course some ways a regular function could do this, but macros can do even neater stuff. This of course is not the point we're going to be going through macros, but what happens is because macros are not like a normal function in the sense that they're not, if we're going to produce evaluations, normal evaluations of values, or normal evaluations or side effects. So basically what we call macro expansion is essentially when the macro runs, right? So the macro goes ahead and it expands out, usually at compile time, and it goes ahead and blows up and basically produces a brand new form that replaces itself, right? So that's the cool thing there, right? And we use def macro to be able to produce, right? In other words, these macros that will expand, right? All right, if function calls, right, for first element it's not a symbol, right, the name's a special form macro, then it's a function call, right? So what happens? So any and all remaining elements of the list are forms to be evaluated, right? So we go ahead and we have that symbol, and then we have a bunch of arguments to the function, right? That's what these represent. The function is then applied to each of the arguments. The functional computation normally produces a value, right? Of course, it's possible to have a exceptional situation and therefore execute the list condition system, or you can do several values, of course, using values, right? So programs are an error that rely on a particular order of evaluation of the first element of a function called relative to the argument forms. So meaning if you calculate what function is going to actually be run, meaning the first parameter, the first member of the list, if that first member of the list could change, that's a really cool little thing about lists just to keep in mind. I'm not going to end up with that, but it's a neat thing. Right. Functions. There are two ways to indicate a function, right? A symbol that names the function, right? That's a named function, or actually an anonymous function, right, which is to use a lambda expression, which basically means you're going to put the parameters right after this word lambda, right, and essentially then you're going to then write out your forms that make up your function body. All right, so name functions are done using defund, right? If they're local, right, I mean if they're in essentially the local scope, we use flet or labels. The difference between the two, flet, they cannot be recursive. Right, so you can have a series of functions, but they can't call themselves all right, or other members of the FLET. And labels is, again, something which allows each one of these functions to call themselves or call each other. All right, so that's what's going on with that. Let's see here. So it's kind of like this is like a let, and this is kind of like your let star. Kind of think about it like that. Okay, lambda expression, right? So again, so you have your lambda list, and your body, right? Lambda lists are also used when we're defining a function with defund, right? Because defund basically says I'm doing a name function. Here's my name, and then again we grab the same lambda list. And that's really the only difference between the anonymous and name functions is one, of course, is name, right? So, but that's the one starts with lambda. Okay, so what's going on here? So you have lambda, right? Then you go ahead. You have our list of parameters, right? And you have some special parameters. So you can have optional parameters. You can say, the next parameter that I have on my list, the rest, anything else afterwards should be stuffed into that in a list form. I mean, you get a list in that var that basically has anything else that's added after whatever you type so far. Key parameters. Now, this is pretty cool stuff. So you can basically, they're named parameters. And what that does is allows you to give a list of names. Right, each one of those names is going to then be accessible in the lambda when you call it by keywords, right, followed by the value that you want to send. You can also, of course, start that with the init form. We'll see that in a moment. And then aux. So aux is a pretty cool thing most people know about. Basically, what it does, it's kind of weird. It's kind of like lets you set up variables for use in the actual function body, right there on the actual parameter line. Okay, it's a throwback from previous lists that existed, but it's there. Okay, so they're not actual parameters. They're just kind of like it's just defined there. Okay, each element of a lambda list is either a parameter specifier or a lambda list keyword, right? So that means the parameter specifier is the actual symbols that represent the various different parameters, and lambda list keyword is one of those keywords that we saw that started with an ampersand over there. Okay, so let's go through them a little bit. So specifiers for the required parameters. So meaning in our parameter list, the first parameters that we place, those are required, right? So in other words, they're not accessed by name, by anything. If you add any parameters immediately, those are all required parameters. And then, of course, everything after the optional is optional. Don't mix, by the way, optional and keyword. Just keyword parameters and optional do not like each other. Don't do it. Okay, just in fact, trust me on it. Okay, a specifier for a real rest parameter. So basically, again, when you get to the end of your required parameters, optional parameters, then you're going to have basically, rest. I mean, anything else that follows goes into the list that's called rest. The rest of the parameters. And specifiers for key parameters, they go after your key. Excuse me, your key lambda list keyword, right? And basically, that's where you add your key followed by the keywords you're going to be using, and then also, like I said, you can have init forms that basically say what those values will equal. Allow other keys allows you to add additional keys, and they actually come in as if you had originally specified them as parameters. So it's a really interesting way to actually have a form that is basically changes depending on its context of what's passed into it and so forth. And of course, we already talked about the aux variable. This just allows the additional presence. Right, he says again of these additional lexically bound variables being added into your function itself there. So again, I don't think I've ever seen it, but it does exist. All right. Okay. So one thing to keep in mind, which is kind of interesting, is you actually do not have to use keywords for the key parameter. So there's actually ways that you can use non-keywords symbols. That's what we're referring to. So for example, if I did super, in other words, and I said the initial value of duper, then super would be accessed by my tasks, parenthesis, :super, and then I would go ahead and put whatever I wanted to pass in instead of the initial value of duper that I set it up. So that's pretty cool. But it's actually possible to use any keyword, any symbol at all, What you have to do, though, of course, is you have to use this format, which is basically the actual symbol you want publicly to be seen. So, for example, like my test, super, that's the public symbol. And this is the private symbol, meaning how it will be referenced in the actual body. A cool little thing. Okay. Okay, what else we can look at? Okay. All right, so Lambda List keywords. All right. Okay, so the value of Lambda List keywords is a list of all Lambda List keywords. This is actually a constant that if you get evaluated, will actually return you basically, most part optional REST key, will actually return this list. And there's a couple others occasionally, depending on what your implementation is. Just tells you what the various keywords that exist are. Lambda parameter limit tells you a positive integer that is the upper exclusive bound on the number of distinct parameter names. Meaning how many parameter names are there. Okay, let's see here. Top level forms. Okay, so the top level special forms may be used to define globally named functions, right? So top level special forms may be used to define globally named functions, to define macros, to make declarations, and to define global values for special variables, right? This is stuff basically that actually executes, right? He says when the various different portions of your file are being loaded in or at the REPL, those are all going to be called top level forms. All right. If it is, this is actually a pretty cool form called Progen, right? That if you go ahead and you use this form any place, everything inside of it is treated as if it was top level, right? And again, we'll come across that topic again of top level in a couple other places. But the key thing is, those are essentially forms which are evaluated immediately at the time, either at the keyboard or in the file as it's being processed, or actually as it's being executed and so on. Okay. All right. They define much of the structure of our software is in the top level forms. All right, define. We'll talk more about that when it's appropriate. All right, defining name macros. To defund special form, this is basically assuming defining name function, right? And we talked about before. Also understand defund setf cater, right? Basically, what happens here is you can have set of functions. This is actually how you specify. Now there is a def setf and a define modify macro. I will tell you that the macros they create havoc when it comes to mixing with the object system. I don't recommend using them, right? It talks about being more convenient than using it. Don't forget about convenience. Do your defund this way, right? Otherwise, you're going to end up it's going to come back to bite you, right? So basically, defund setf, and you go ahead, and that basically will allow you to set up a setf function to be able to a reader and a writer, right? So this is your writer and your reader, for example, if you're using methods. And these actually methods are done the same way. Okay, docstring, right? So that basically one of my favorite parts of Linux, my favorite parts of Lisp, is actually docstrings. The fact that I can document very clearly in a known set place that what is going to be, right? In other words, a description of my function, right? Very simple, not processed really other than that. It does actually get fed into the system and held on to unless you've set not to. But declare can come before docstring. That's about the only thing that can come before. Now, by the way, the reason for that is very much declares, as we we haven't spoken about yet. We will soon. Declares and the various other types of directives, so to speak, that they really are directives to us more than they are to the compiler, right? So the fact that number ABC is really actually documentation to us, the developer. It happens to be that compilers like SBCL, they'll make use of this in other words, for some neat little static typing type of stuff. But for the most part, though, this is really a directive to us, so that makes sense. It's actually documentation. So the body of the defined function is implicitly enclosed in a block, and therefore return from, which I mentioned before, works, right? So you can actually go ahead and you can write a function, right, that does a return from my test right there in the middle, boop, return, and it goes ahead and returns that value. So you can actually have a return just like most other languages. Okay, permissible use to use defund to redefine a function. That case, you have one function you want to redefine it. We do it all the time, for example, the REPL or when we're developing. But this can be done actually even during runtime. It's permissible to redefine a macro as a function, right? So that's also possible as well, or vice versa. Let's see here. The issues become when you start getting into generic functions and things like that. But again, we'll talk about some other time. Okay, so declaring global variables and named constants, right? So any global variable, it really is defining it special, right? So defvar, def parameter, these are going to be special variables. Defvar does not change the value of the variable. If no initial value form is provided and the variable has no value, then it's essentially an unbound or valueless variable. But there's no initial value, so it's set. So if you don't put anything there, it's unbound, right? So just keep that in mind. You're actually going to find that in a number of different places. That again, anything on that global, let's use scope. That global scope is basically going to end up, if you don't assign it an initial value, it is unbound. Initial value form is evaluated if and only if the variable does not already have a value. So what that means is that when you do a defvar, right, you actually can set an initial value in the actual defvar. So defvar, right, the variable name, and then an initial value. So let's say, for example, you run your program a second time or third time from the REPL. Well, what's going to happen is if it already has a value, right, it's not going to set the initial value. So this basically, it starts with this value and it stays with the value, no matter how many times you run your program, and even if it's changed that variable many times, if it has a value, meaning if it's already been bound, it has a bound value, that's it. It's not going to change it again. Right? Just keep that in mind. Def parameter requires an initial value form and always evaluates the form, which means, again, no matter how many times you run your program, right, he says that the initial value will remain the value, that whatever you put in there, right, that's going to replace whatever is going on in your life, your live system, and assigns the value, the result of the variable. Okay. Assigns the result to the variable, sorry. Okay, so def constant. So again, compiler must take care that copies appear to be EQL to the object that is the actual value of the constant. That's what I mentioned before. The result of this, def constant creates issues with strings and lists, as each valuation will not be EQL to the next. And we only use numbers and symbols, right? Def constant always refers to its global value. It's actually, at least in SPCL, it actually creates a condition that basically says, hey, you can't redefine an let, for example, a def constant. But theoretically speaking, I guess I think it's part of the standard now, but it is possible some old versions may not give you an actual error, or basically throw a condition if in fact you did that. So just keep that in mind. Def constant will always equal the global value. All right. Okay. Yeah, this is okay. So first of all, a whole bunch of stuff changed with the value when in the book. So that whole section is rewritten again in Common Lisp second edition. And so let's talk about this, right? So each situation, now eval when, what it does is you give the situation, right, is in your first list, and then you basically have a series of forms, right, and then again you end your eval when, and that basically is going to be conditionally, let's say, I don't want to use let's say there's various different situations when the code will be executed or not, right? So compile top level, load top level, execute. Now I'm going to give you a summary of it here that pretty much should take care of most, if almost all, situations. And it's a little bit, certainly a lot easier than the text that's in here. And it's not something necessarily practical unless you're like doing some serious macro writing, going to come across the use of eval when anyways. So make sure the eval when block has been evaluated during, I mean that block that basically all those forms that make up, right, the body of eval when, essentially if you put in the situation compile top level, and by the way, usually it's all three of them, right, are put in the situation. But what it does is it ensures that at compile time, this code is going to be available, right? So for example, let's say I write a macro that's going to expand at compile time. I want to make sure that a certain function is there. So compile top level. And by the way, when does compile top level actually even come about? That situation when you're using compile files. So during a compile file, compile top level, this particular situation exists, and that therefore at compile time and available for macros during compile time, right? Load top level. Okay, so this is essentially, you didn't use compile file, you used load. You loaded the file in. Again, today everything seems to be more or less compiled. Most, well, not most, but many of the versions like SPCL compile everything. But they also they load in, in other words, and then compile as it comes in. And when a couple tests it seems to say that it still comes under the load situation. So load top level, I'm loading a file right into my REPL, for example. So what happens? Load time from a compiled file or used by macros to execute at load time, right? So this ensures that whatever is inside the eval when is available during load time. Right, so I want a specific function to make sure it's available at load time. That's the way I would ensure it to be. And execute is the regular normal code. It's the regular normal situation, right? So you're executing something at the REPL, then you're in execute time, meaning that's the situation that you're in. So again, it's certainly, you can spend the time going through this, but like I said, pretty much the only time you're going to end up making use of this, if you want to make available a specific function or various global level, global scope type things, I want to make sure they exist at the time my macro is expanding. And then essentially I would make sure that they're in an eval when block and compile top level is there, along with low top level and execute as well. Okay, and I think that takes care of this chapter. All right.